Hello students, let us discuss preparation of haloalkanes and haloarenes in this video. Haloalkanes are generally prepared in the laboratory by following methods. These are can be prepared from alcohol, from hydrocarbon, halogen exchange reaction, by electrophilic substitution, sand-Mace reaction. Let us discuss these reactions in detail one by one. Let us first discuss preparation of haloalkane from alcohol. This is the most widely used method for the preparation of haloalkanes in the laboratory. The hydroxy group of alcohol is replaced by the halogen atoms, that is X, and it takes place when the alcohol react with halogen acids like HCl, HBr, HI, phosphorus halides or thionyl chloride. So for this equation you need to remember the hint, that is remove the OH group, that means replace the OH group from a alcohol and keep a X, that is a halogen atom in the place of OH. So whatever the alkyl group, it's not matter, you need to just change the OH with the X. Let us discuss these reaction in detail. Alcohols can be converted into halides by treating with the halogen acid, that is represented by HX in the presence of zinc chloride, or when it is treated with the NaX in the presence of H2SO4, or while treated with the phosphorus trihalide, it gives rise to halide, or by treating with phosphorus pentachloride, it gives a halide, or treating with the X2, that is it can be chlorine, bromine, etc. In the presence of red phosphorus, it gives halide, and when it is treated with thionyl chloride, that is SOCl2, it gives rise to halides. So in all these processes, that means in all sort of reaction which is shown here, in all these places the OH is replaced by X. You can check in all these, OH is replaced by X and the alkyl group is present as it is in all the examples. So in all these equation, main product are the same but they have different side product. Let us check what are the different side product in each case. So this is the detailed equation which is given for the reaction of alcohol with HX, NaBr, PX3, PCl5 with X2 in the presence of red phosphorus and with thionyl chloride. In all these you can check the main product is an haloalkane but the side product is different. So usually in the equation main product are important for the when we are doing for conversions and all. Next we will be discussing the preparation of haloalkane from hydrocarbon. Hydrocarbon means the compound made up of carbon and hydrogen only. So first we will talk about alkanes and then about alkenes. So let us discuss preparation of haloalkane from alkanes. This is a familiar reaction for you. Last year in 11th standard we have discussed about this reaction, that is free radical halogenation reaction of alkanes. It takes place in the presence of a UV light. That means alkanes when it react with the chlorine in the presence of UV light, it gives rise to haloalkanes. This reaction gives a mixture of mono, di or polysubstituted haloalkanes, and which is quite difficult to separate into pure components. So in this equation also you can see that one of the hydrogen atom is replaced by Cl. So here if the first hydrogen is replaced into Cl, it gives us to the first product, and when the second hydrogen is replaced by chloro group, then it gives the one more product. So it will give a isomers. It gives more than one product, or we can say it gives mixtures of mono, di or poly substituted haloalkanes. In alkanes, two type of reactions are there, that is addition of HX, addition of X2. Let us first discuss the first one, that is addition of HX. HX is a halogen acid. The reaction with HX, this is also we discussed last year in 11th standard, that is in the properties of alkenes. That means if the alkenes are symmetrical, then we need not to use any rule and we can directly keep a hydrogen and X in the reaction. But when there is a unsymmetrical alkene, we need to use Markovnikov rule and anti-Markovnikov rule. Depending upon if the presence of peroxide is there, we have to use anti-Markovnikov rule. Let us discuss with example. In symmetrical alkenes, the two carbon atom that is double bonded are of similar type. That means both have same number of hydrogen atom. This is called as symmetrical alkene. When HX is added at the time, H get added on one of the carbon atom and X get added on the another carbon atom. So double bond breaks and result in the formation of this compound. So in this compound you can check that hydrogen is added on this carbon atom and X is added on the another carbon atom. That is the example of a symmetrical alkene. Let us take one more example in symmetrical alkene. In this compound, there is a double bond. These two carbon are our focusing carbon. So here also both the carbons are similar type. They have same number of hydrogen. And when HX is added, so on one of the carbon atom we need to add H and in another carbon atom we need to add X. Let I'm adding H on the side and X on the side. So double bond break and result in the formation of halide. So you can check that X is on this carbon atom and H is added on this carbon atom. Because it is a bond line structure, so it is not represented. So in the symmetrical alkenes, there is no need of rule. You can add H and X on any of the carbon atom which is double bonded. But in the case of unsymmetrical alkene, we need to follow rule. This rule last year we discussed in the class, that is Markovnikov rule and anti-Markovnikov rule. Let us discuss this once again. If the alkene is unsymmetrical, that means this is an alkene which is unsymmetrical. You can check the focusing area is these two carbon atoms. That means double bonded carbon atoms are the focusing area. So when you check, there are two hydrogen atom on this carbon atom and there is one hydrogen atom on this carbon atom. So when HX is added at the time, it is observed that the negative part, it should be added on the carbon atom which have less number of hydrogen atom and the H get added to the other carbon atom. So when you add these in this way, we'll be getting this product. But if the reaction is taking place, that is the reaction with HX in the presence of peroxide, at the time we need to use anti-Markovnikov rule. According to the anti-Markovnikov rule, when the HX is added, at the time the negative part get added to the carbon atom which is having more number of hydrogen atoms. So when you compare these two carbon atoms, which have greater number of hydrogen? This carbon. So X get added on this carbon and the H will get added on this carbon. So we get this product. So in both the cases you are getting different product. So that means whenever there is an unsymmetrical alkene, you need to follow the rule and then you need to make the product. Next is the reaction of alkene with X2. Here X2 can be bromine, chlorine, etc. If the alkene is treated with X2 in the presence of CCl4, it gives rise to weak dihalides. That means in this case both the chlorine, or we can say both the halo group get added. So one X get added on this carbon, the other X get added on this carbon. The double bond break, it make to single. So we get this product. So in this product, the two halo group are added on the adjacent carbon atom. Such type of dihalides is called as weak dihalide. In the next example also we can find, this is our focusing area, and one of the X added on this carbon atom and other X get added on this carbon after the breaking of double bond. So we get this product. In this also we can find that two halo group are attached on the two adjacent carbon atom. Therefore it is called as weak dihalide. It is one of the important tests for the detection of double bond in the laboratory. That is the reaction of alkene with bromine in the presence of CCl4. Next we will be going to discuss preparation of haloalkanes from halogen exchange reaction. Halogen exchange reaction. What do you mean by exchange? That means there is an exchange of halogen here. That means one halogen is exchanged by the other halogen atom. Then it is called as halogen exchange reaction. Let us take the first example. In this case, Rx is our one of the haloalkane, and when it is treated with NaI, that is sodium iodide. So in this place, in the place of X, I is taken this position, and so we get a product Ri plus NaX. So you can check in this product, in the place of X, now there is an I. So here it is an exchanging of a halogen is taking place. Therefore it is an halogen exchange reaction, and this reaction is a name reaction that is called as Finkelstein reaction. Let us take the second example. In this example also the halogen are exchanging. That means from in the haloalkane there is Br here, and when it is treated with AgF, then in the place of Br, F take. So we can say that we get a product Rf plus AgBr. So when you check the reactant and product, you can find that there is an exchange of halogen atoms during this reaction. So such reaction is called as halogen exchange reaction, and this reaction, particularly this reaction, is called as Schwarz reaction. It is also one of the name reaction. In the Schwarz reaction, in the place of AgF, we can use SbF3, Hg2F2 and even COF3. So in these are the reactant which can be used for the formation of fluorides from any other haloalkane. So while doing the conversions or while doing the reactions, complete the reactions, always we need to remember that whenever we need to exchange the halogen atoms from a haloalkane, these two reactions are the most useful reactions. And in this reaction, one more thing we need to remember that always whenever we need to prepare a fluoro compound, that means alkyl fluoride, we need to use Schwarz method, and whenever we need to make an iodide compound, we generally use Finkelstein reaction. These are the two name reactions, so we need to list out the name reaction in a separate paper. So you need to list these two in name reaction list. Next is preparation by electrophilic substitution reaction. That means the haloarenes usually prepared by this method, that is electrophilic substitution reaction. Last year we also discussed this equation, electrophilic substitution reaction. In this toluene, this is toluene. It is an hydrocarbon having a benzene ring. When it is treated with X2 in the presence of Fe, we get two product, that is first product. In this product X is at the ortho position, and in the second product X is at the para position. When you check this, it is a para position, this is ortho position. That means we get a two product, ortho substituted product and para substituted product. In the second equation, that means particularly in the place of X2 we are taking chlorine, so we are getting the two product, that is ortho substituted product and para substituted product. This first product is called as orthochlorotoluene and second one is called as para-chlorotoluene. So these are the two products which is formed from electrophilic substitution reaction. So in this way we can prepare haloarenes. Now there are some special reactions which are usually name reaction that we need to discuss, and these methods are usually used for preparing haloarenes. First of all, discuss the first equation. In the first equation, this is aniline. Aniline treated with NaNO2 and HX, we get benzene disonium chloride. Check the formula, benzene disonium chloride having benzene ring and on which N2X. This is benzene disonium halide. From this benzene disonium halide we can prepare a number of haloarenes. So let us first prepare a halo compound from benzene disonium halide. That means benzene disonium halide treated with the Cu2X2, it gives rise to a aryl halide. You can check in this part N2 is removed and we get this aryl halide. This reaction is called as Sandmeier's reaction. Next reaction. In the next reaction again the benzene disonium chloride is treated with the Cu, that is copper, and HX. At the time we are getting a product that is aryl halide, and here X can be Cl and Br. Here also N2 is one of the side product. This reaction is called as Gutermann reaction. Next reaction. In this benzene disonium chloride treated with HbF4 give rise to a compound, that is fluoro compound of is given by this reaction. This reaction is called as Bals-Kaiman reaction. That means we get fluorobenzene by this method. And the last method, in this benzene disonium chloride or halide is treated with Ki. It gives idobenzene. So these are the name reaction, that is diazotization reaction, Sandmeier's reaction, Gutermann reaction, Bals-Kaiman reaction. So usually the idobenzene are prepared by this method, and usually the fluorobenzenes are prepared by Bals-Kaiman method. So these are the important methods of preparing, that is aryl halide are usually prepared by these method. So in this video we discussed about the preparation of haloalkane and haloarene. From this we have discussed the preparation from alcohol, from hydrocarbon, that means from alkanes we can prepare alkenes, from we can prepare and halogen exchange reaction, in which we discussed Finkelstein and Swart reaction, electrophilic substitution reaction. Usually the haloarenes are prepared by electrophilic substitution reaction, and some special reactions we discussed about the preparation of haloarene. So in the next video, we'll be discussing the further details. Thank you everyone.